what was going on with Discord. So let's roll into this. Let me pull up my screen and share it. I might even have a little special something. We're going to try something different actually today. Well, we were until it broke. So let's just stick with our tried and true that we were using before. The demo gods are not being kind to me today. All right, let's share our screen and let's get into it. So for those of you who are here for the first time, this is event 3. Welcome. I'm Michael Forrester. Forget my lack of KodeKloud shirt. I don't know why, but today I'm wearing a Hawaiian shirt. We are going to go through KCNA, actually. And we're going to go through a specific domain of the KCNA test. Now, for those of you who are not familiar, this is the Kubernetes Certified Network Associate. I think it's, or Cloud Native Associate, Kubernetes Cloud Native Associate. It's basically the exam that you use to get into the whole kind of CKA, CKS, CKAD kind of ecosystem. Think of this as like AZ900 or like Cloud Practitioner for the CNCF landscape. And so what we're going to do today is I'm going to pull up some questions and we're actually going to go through them. And what we're going to do is we're going to play a guessing game. We're going to read a question. It's going to have A, B, C, or D. You're going to put A, B, C, or D in chat. This is why everyone was joking that all the answers were B last time. And we're going to just explore the rationale for how these questions go. Now, what you may not have heard earlier, because I was just talking into the abyss of my mic, is that for those of you who've done CKA, CKS, or CKAD, you're going to be shocked at how relatively easy the questions are. For those of you who are new to the CNCF landscape, this is going to give you a feel for the shallowness, like the superficialness, this like really like low level of the KCNA questions. So this should build your confidence to take the exam. I can also answer most questions about Kubernetes and its associated friends because I did my first production deployment of Kubernetes back in 2017, and I have done a lot since. So hopefully you know that I'm one of the instructors for KodeKloud. Maybe you've even seen a class or two of mine. But let's get into it. Okay. As usual, I will try and keep the answers off the screen, but if for some reason there has been some misformatting, which has shown up once or twice, I ask you to bear with me. Oddly enough, sometimes the formatting just rolls back somehow. We got too many chefs in the kitchen sometimes. So, all right, let's share the screen. Let's get going. All right. Currently, you should probably see my screen and maybe even me messing around trying to make the thing a little bit more interactive. So let's talk about it. All right, so for those of you who are not familiar, Domain 3 actually is the Cloud Native Architecture section. So this is the section where we're going to cover things like autoscaling, serverless, roles, personas, open standards, right? So questions look like this. And by the way, you can go ahead and answer at any time, so you don't need to wait on me, right? What's the primary benefit of autoscaling in cloud native applications? Is it A, to reduce application time, B, to automatically adjust resources, C, encrypt data transmissions, or D, to store application configuration data? Oh, am I just sharing Discord? Oh yeah, look at that. Oh, this is just a comedy of errors, isn't it? Let's try that again. There we go. Here's the questions. All right. So this is kind of what we're going to do, is we're going to run through the cloud native architectures. So autoscaling, what do we use it for? By the way, the fact that the first answer is B is giving me a bad feeling about like whether or not this was actually adjusted for distributions. So maybe we'll just be running back through restudy here. Huh. Was this actually corrected? Because it should have been. I could have sworn that I remember redoing a machine learning algorithm to do weight distributions. Anyway, all right. So as you can see, this is the like level of questions that we're at, right? Oh, by the way, I have a link for the recordings and for both 1 and 2. So this will go into that. If you haven't seen it, I'll share it actually before we get off the stream. And then, yeah, this whole document will be provided. So, all right, let's do it. All right, so I would say that obviously the primary benefits of auto scaling in cloud native applications is, of course, mainly that it's to adjust resources on demand. And the reason we love that is exactly as it says, is that it's going to optimize costs and it's going to optimize performance, right? And those are the two kind of poles that we're always dealing with, right? Because if we had unlimited money, we would just make everything super high performing. But we don't have unlimited money because we live in the real world and we're not billionaires. And so therefore, right. Okay, question number 2. Oh, and by the way, the document contains all of, my explanations and whatnot. Indeed. Hyperscale cloud providers are indeed billionaires, right? What did someone say to me the other day? Billionaires are people too. I was like, yeah, I didn't think they weren't. Okay. So which Kubernetes resource automatically scales the number of pod replicas based on CPU utilization? Well, first of all, I just want to mention that could be slightly misleading because you could use other dimensions. But yes, CPU utilization. If you want to scale the number of pods, not the nodes, right? Not upsizing, but horizontal scaling, right? What do you do? So you want to scale the number of pod instances, not the size of the pods, right? Yeah. I see a lot here. The number of pods, right, is going to do pod replicas, yes? Whereas if you are adjusting the resources allocated, right, are we not using vertical pod autoscaler? Yeah. So the idea here is that are we adding more copies of our application or are we actually upsizing the application we have? Now, what's the problem, by the way, with upscaling applications prior to 1.32 of Kubernetes? So why do I say prior to 1.32, right? Is that you're going to cause a little bit of a disruption unless you have multiples. You're going to do pod restarts, right? So the issue here is that, depending on the nature of the thing in question, you may not be able to get away with that, right? I will say that I want to say it's 1.32 or 1.33, the most recent releases of Kubernetes, they've added dynamic upsizing, which allows you basically to scale CPU and memory on demand. Like you can actually like upsize the pod while it's live. I have to say, that's a pretty cool new feature. I think I'm on 1.33 in my home cluster, but I haven't tested that yet. I don't think I have any production clusters that are currently doing that. So, yeah, we'll see how that rolls out. But hopefully that makes sense. Here's the question again. Yeah, number of pod replicas. Good. All right. I believe that's correct, Shanu. Right? I mean, most of us are using deployments to wrap around that whole replica set conversation. Replication controllers have definitely been deprecated for a while, or at least headed towards deprecation. So, okay. Here's question 3. What is serverless computing? I always think of serverless, by the way, as not really like no servers, but basically you don't get to see the servers. The servers are hidden. Who hides them? Right? Yeah, it's never no server, Cat. That's a real good way to say it. It's never no server. Even the other day, someone said, well, we're just going to use serverless in our cluster on premise. And I was like, well, I mean, yeah, absolutely. That's a great idea. Who's going to manage the virtual machines and everything else underneath the server? He's like, well, it's serverless. And I was like, yeah, we're going to come to a consensus. So what is serverless computing? So computing without any servers involved. I wish, you know, I know as engineers we love messing with things. It would be nice also to live in a world where you could just like put hardware out and it just kind of auto set up. But don't worry, give the AI time, it'll get there. B, cloud computing model where cloud providers manage service infrastructure automatically. C, a way to store database without databases. And D, a method to run applications without containers. All right, obviously we may be running into our distribution problem. The answer is B. So cloud computing model where the serverless provider manages server infrastructure automatically. Now here's a trick question. Yeah, the ML thing didn't happen, Kat. I even spent time on it. You may have even seen some of the work I was going back and forth with Claude around like, did I get this right? Anyway, I guess it didn't work. So here's the question is that, does anyone know what we, like let's pick on AWS for a second. Do you know what AWS actually uses to run serverless? Anyone take a guess, right? It was probably me. Okay. What, like when AWS, for example, launches a container and it's using their serverless thing, Fargate, or even when they launch Lambda, for example, what is the underlying unit that they use for that? Right? Is it Kubernetes? Is it a container? Is it Docker? Like, what do they use for that? Does anyone know? Because there's a whole paper written on this, and for AWS, Azure, and for I think Google does it slightly differently. Does anyone know whether they're using servers, virtual machines, or containers to run serverless? Yeah. So for those of you who may not know, look up the word Firecracker VMs. They're actually using many virtual machines to run their serverless infrastructure. And this is how they can get away with you using containers or not containers, right? Is that they're actually running these little mini virtual machines called Firecracker VMs. So like if you ask for a 1 gig like pod, for example, or like, container, what they actually do is they run a virtual machine that has 1.1 gigs of memory as an example. So they use these Firecracker VMs. It's really cool, actually. All right, enough digression. Let's talk about this. Hopefully this makes sense. Serverless computing is other people's servers, basically. Okay, which of the following is an example of a serverless platform? Okay, so remember that, this is really a test to see if you know about the cloud native landscape. So, do you know what Kubernetes is used for? Do you know what etcd is used for? Docker, is kind of the grandparent, if you will, of the CNCF. So, they talk about that even though it's not a CNCF project. So, next to Solaire, you were asking about Fargate. So Fargate is the name that AWS gives to all of their serverless backend stuff. It's actually not, it's an internal service that they use. They advertise it like it's an external service. You can only use Fargate with Kubernetes, ECS and EKS. They're two like containerization services. So you'll hear them talk about it as if it's a separate service. Like, I used Fargate. No, you didn't. You used ECS or EKS. You used either the Kubernetes service or the Elastic Container Service. So anyway, back to this question. So which of the following is an example of a serverless platform, right? So to be clear, this is a container orchestration platform. This, right, is basically a packaging system for process virtualization. This is a distributed key store database, right? So even by elimination, it kind of just leaves Knative as the thing, right? And so if we look, yeah, Knative is actually the serverless kind of project, if you will, for this, CNCF, for lack of a better word. So this is the one that, scales to 0. This is the one that does event-driven architecture. This is the one that does, it basically takes your Kubernetes cluster and helps it evolve it into a serverless platform. This is the conversation I was having the other day where the gentleman's like, we'll just run Knative and then we don't have to worry about managing our servers. And I was like, well, hold on. Like, it's like people think you don't have to manage virtual machines once you launch Kubernetes. Virtual machines or some kind of operating system is still required to run your containers. So the answer for this in this particular case is going to be Knative because that is actually the project that does serverless. So one thing you will have to pay attention to is that if you haven't actually memorized the CNCF landscape, you don't. And just to show you this, if you haven't memorized, and I'm going to show you how you filter it, because otherwise it's just a tremendous amount. You click on filter and then you uncheck everything except like archived. This is the CNCF landscape, and I know you're like, ugh, Michael, my brain hurts. Mine too, because I don't realize why it did not filter everything out. Graduated, incubating, sandbox, nothing else. Huh. I wonder why it left all this stuff in there. Hold on 1 second. Anyway, I don't know. It must be broken. Anyway, all the big boxes here, this is all part of the CNCF landscape. Ignore this. There must be some kind of issue because the filter should just do the CNCF projects. But regardless, should be the entire thing. And so this is incubating. This is graduated. Oh, these might be sandbox, actually. Actually, they are sandbox. So at the very least, you want to be familiar with the graduated and the incubating, because these big boxes here, they're going to ask you questions about the top like 20 of them, right? So KDA, for example, which is basically the event-driven autoscaler, obviously Kubernetes, obviously Crossplane. Here's Knative. This is the whole reason I showed you this, is that in general, you probably want to, and you know what, here's what I'll do, is I'll actually just give you a quiz set that tests your ability to recall what these big ones do. So I'll just actually generate a quiz for you and send it to you. We'll talk about it the next time we meet, our last event. But like, you need to know what Longhorn and Rook is, and you need to know what cert, hopefully you know what Cert Manager is, right? So just know, I'll generate a quiz for next time, one that actually works and has actually proper distribution. Either that or I'll just make all the right answers B. And anyway, here's Harbor. Dragonfly is not used a whole lot, but here's Spiff and Spire. So, you want to get familiar with what these things are, because they will actually ask you questions about them. Meanwhile, back to this. So in that case, Knative is actually the project for serverless. Okay. Again, I'll share this PDF with you, but should be there. Let's do question 5. What does scale to 0 mean? I actually just said this a few minutes ago. What does it mean in serverless computing? Cat's like, Michael, you didn't really change this from last time, so I already know that B is the right answer. Now, I want to say this, scale to 0 basically means that if you have inherent auto-scaling capabilities inside of a system that you're not really managing, or you could be managing, what we'd like to do is that we want to make it so that when we're not using the system, the resources don't cost us anything. And that's the ideal, right? Now, we might still have to pay for cluster management, but I want the actual kind of, in a sense, hosts that host the containers, I want them to go to 0. So scale to 0 is kind of like the golden ideal when it comes to serverless, or when it comes to auto-scaling. Auto-scaling is the secret sauce that cloud providers introduced that actually made cloud super attractive. And this is also why when people go into cloud and they don't use auto-scaling, they're usually paying through the nose. It's just like expensive data center 2.0. So scale to 0 is an important concept both in serverless computing and in auto-scaling, because we want to scale down to 0 when things are not at use. If it's 3 o'clock in the morning on a Saturday, how many people are actually using your logistics app for, a dentist or a doctor? At 3 o'clock in the morning on a Saturday? 3 a.m.? Probably not a whole lot. So the scale to 0 thing is important, because this is how we get down, right? So the right answer here in this particular case is B. Scales down to 0. 0 running instances when not in use. This is, by the way, why things like Fargate from AWS, or the Azure Container Service, like, right, I didn't even say that right. AKS, the Azure Kubernetes Service, has some of the ability to scale down to 0. This is why also when people complain, when like GCP or anybody is like, oh, hey, we've got a new serverless option, but it doesn't scale down to 0, that really makes people mad. Because if you don't scale down to 0, then that means you're paying for it when you don't need it, actually. So Kat just to say this, what if you are someone who provides a dentist appointment scheduler to thousands of dentists? Then you probably want it to scale down to 0, right? Yeah. All right, so scale to 0 is the answer. All right, let's look at question number 6. What is the Cloud Native Computing Foundation? Now, that's a good question, actually. My only response to that, Cat, when you were like, hey, maybe you need it globally. If you're running a single Kubernetes cluster that's feeding out the entire world, man, I hope your content distribution network is really, really good, because you probably need multiple clusters to cover global demand, right? So then the cluster that's in North America at 3 a.m. probably could scale down to 0, and you could just use your, European cluster or your whatever Asian cluster, right? You wouldn't run a single cluster in a single location for a global service. It wouldn't provide, it would be geo distributed. So Cloud Native Computing Foundation is a consortium of both big businesses, communities, and individuals, basically, that host cloud native projects and promotes cloud native computing. I want to say that the CNCF was, I want to say it was founded in like 2014 or something like that. Yeah. So if you're, basically the CNCF has pretty much set the tone for these cool open source projects, starting, I think, with Kubernetes was the first one, although several were inducted at the time. I don't think Kubernetes was actually even the first one inducted, but I think Kubernetes was the first one to reach graduated. And so this is just a foundation that hosts the native projects and promotes cloud native computing. So, cncf.io, if I remember correctly, right? This is the Cloud Native Computing Foundation. If you've never been to one of their conferences, they're usually tons of fun. Obviously, you can see here that they have a bunch of graduated projects incubating. We were just looking at the landscape a little while ago. They are a part of the Linux Foundation, right? And the Linux Foundation is probably one of the largest, as it says here, places to go to basically scale open technology projects. So, everything from Linux to, what else is in here? There's a bunch in the Linux. Their summits are usually like, you can see it in the upper left hand side, the open source summit, which I've been to several and spoken at quite a few. And they're also really fun, and they are all over the world as well. Like the CNCF is about to have a KubeCon, a Kubernetes conference, which is really a CNCF conference in Japan. So I know I really wanted to go to that one. Was the CNCF created off of Kate's? I want to say, Kat, like the first project that was sandboxed was actually not Kubernetes. I believe that's right. But I think the idea, like, it coalesced around Kubernetes. Kubernetes was the one that kind of like brought it all together and made it a big thing. So yeah, Kubernetes was the herald, right? I mean, I just want to say this is that pretty much all of these tools center around Kubernetes, do they not? So Kubernetes is pretty much the main thing. It's like saying that, like, I don't know, you got a superhero team and there's always the one guy or one who's like the center, and you're like, that's the leader. Kubernetes is the leader. Okay, so for those of you watching, CNCF is basically an open source foundation that hosts cloud native projects. Okay, question 7. This is kind of a gimme. I will say this though. These are the like types of questions that you get in the KCNA. Which of the following is the CNCF graduate project? Microsoft Azure, Google's Cloud Platform, Amazon Web Services, or Kubernetes? I actually took the KCNA 2 months ago to re-up, and it really is like this, right? So in this case, like, even just through elimination, you're like, okay, well, it's not Google, it's not Amazon, it's not Microsoft. Yeah. Do note that they, while Amazon, Microsoft, and Google arguably are part of the CNCF, they're big backers of the CNCF. Obviously, Kubernetes is the answer in this one. By the way, they do actually retire projects. So when we were looking at the landscape earlier, notice I unchecked archived. There are projects out there. If it doesn't have a healthy contributor community, they do retire it, just FYI. Oh man, I didn't do that right. Sorry. I already knew what the answer was anyway. Let's go take a look at it. All right, what's the primary role of a platform engineer in cloud native environments? Okay, so this is worth talking about because if you don't know, Shanu and Rade, thank you. If you don't know, there is a new CNPA certification that just allowed scheduling yesterday. The CNPA is the Cloud Native Platform Engineering Associates. The CNPA is a new exam that is very similar to the KCNA. So just so you're aware, they will ask you platform engineering questions on the KCNA, but at a very shallow level. But there is a brand new certification that you could literally just yesterday, you can start scheduling, which I actually did. CNPA, Cloud Native Platform Engineering Associates. And it's just like this exam. It is multiple choice. It is relatively shallow, but it covers all things platform engineering. So just be aware of that. We're actually releasing a whole course for it in July. All right, that being said, what is the primary role of platform engineer? I saw some of you put your answers. I know it was so difficult to guess, right? And Kat, I don't know why, but they just call it CNPA. I think they're just keeping it to four-letter acronyms. I have no idea why. So the primary role of a platform engineer. So think of it this way. You've got Linux and Windows admins, right? That's your simple, this is where you start. You start with systems administration, right? So you either learn how to administer Linux or you learn how to administer Windows. Then, once you've mastered an operating system at some level, I say mastered, like you're familiar with it. Then you move on to delivering software onto those operating systems. So you learn a little bit about CI/CD because you've already learned about monitoring and logging and like operating system stuff over here. Now you're gonna take that same idea and you're gonna go into like CI/CD, right? So you're gonna become a DevOps engineer. Now, a DevOps engineer usually has an area of specialty. So you've gone from an operating system specialist like Linux or Windows to a DevOps engineer. And now what you're doing is you are delivering software onto a platform. So usually DevOps engineers have an area of speciality. Like, for example, you guys all answer for me. Like, what's your area of speciality? Do you specialize in Kubernetes, which, by the way, could run across all the cloud providers? Do you specialize in AWS? Do you specialize in Azure? Or do you specialize in Google? Sometimes you'll have two of those. Sometimes you might have three of those. I rarely have met people, although I do know some that can do all four: GCP, Azure, AWS, and then sometimes there's a fifth in there, like Oracle or whatever. But the idea is that you're a DevOps engineer delivering software, and you have a platform specialty, right? Then after you like get a decent at being a DevOps engineer with a platform specialty, then you can usually either become an SRE, like I mean a real SRE, not like I haven't read the SRE handbooks and I just have the title of SRE, right? If you haven't read the SRE workbooks for Google and you don't practice the principles in the SRE workbook, then you're probably not a site reliability engineer. Just to say this, I know that's pretty bold, right? But then the other path you can take is that you can be a platform engineer. And the reason I'm bringing this up is that a platform engineer is trying to basically recreate AWS or Azure or GCP. And why do I say recreate? Because you're trying to create a self-service portal that is API driven that solves a lot of the infrastructure and delivery concerns. Now, there's a little bit more to it than just like recreating AWS. But the idea is that you are creating an internal developer platform that developers are going to use so that they can just code and you're going to offer all of the infrastructure and all of the pipeline stuff as a service. So that's what a platform engineer does is they don't manage customer relationships primarily, although they do. They don't necessarily handle financial planning for cloud costs, although they can. That's not their primary role, right? To write application business logic is definitely not their role. Their primary role is to offer an internal developer platform that developers are going to use. That's their role. So that's really what a platform engineer is all about, and it is usually a higher tier of services. Yeah, Kat, I know, like you're trying to create a CSP from scratch. Think of it as like you're trying to create one little microservice of a CSP from scratch. Like you're trying to offer a delivery mechanism onto like EC2 or Azure Virtual Machines. Like you're trying to recreate something that's just a small microcosm of what a CSP does. I mean, isn't that true? Right? I mean, you're trying to create an API driven platform that delivers software into, right? I know, but I agree with you, by the way. Doesn't AWS and Azure and GCP, don't they already do that? Doesn't Oracle already do that? Doesn't Heroku already do that? If we even went down the hosting thing, don't we have like Vercel and Railway and a bunch of other pieces that already do that? Yes, but people have internal concerns and they want to run things themselves. And so you need a platform engineer's perspective to actually run an internal IDP. It's a big deal. And it's also a thought process because this is a lot more about design and customer experience than most engineers will think about. Okay. Haha. All right, what's the main responsibility of a site reliability engineer? Um, it's not just for cost motivation, Kat, to answer your question. It's also just because they want to make sure that delivery is as frictionless as possible. And by the way, your internal IDP could wrap around cloud also. Shadow, you already knew it was B because apparently I don't ML very well apparently, or at least I can't copy and paste my ML outputs. So you already knew it was answer. Let's see. Main responsibility of SRE basically is that it's not. Notice it says main responsibility. It's not about new application features. It's not user interfaces. It's not security audits. Oddly enough, a site reliability engineer is usually a bigger coder than other people. So oddly enough, they're usually deeper into the kind of feature programmer. I can actually code stuff. So they could actually help with some of these things, but they don't typically do that. Their main focus is just on the systems, like how do we get that reliable, available, performant, that kind of thing. If you're not familiar with the principles of like toil and SLOs, SLIs, SLAs, um, incident response, there is a whole free handbook on site reliability that you can get from Google. Right? Let's go take a look at it. Ah, thank you for beating me to it, Kat. I appreciate that. Because, I'm not always the fastest at looking these things up. But there's the workbook. There's actually 3 books. There's 2 of them. There's the practical book. There's the workbook. And then they actually offered another free book. I can't remember the name of it. I remember. I actually, oddly enough, remember the cover. But it's all like free. You can. Oh, here it is. Here's the books. So site reliability workbook, site reliability engineering, and then building secure and reliable systems. So all of these are available online to read for free. You can also buy the books if you want them. I will say that in order, I would read them. I would read the SRE book, I would do the workbook, and then I would do the building secure and reliable systems. This is the most recent book, but if you look at the online copies, you'll see, assuming that I don't make it too small for you to read, you learn the principles about SLOs, distributed systems, right? The evolution of this. Then you learn about practices like practical practices, everything from incident management to troubleshooting, tracking outages, et cetera, et cetera. And then a little bit about management, and then just some things that they've picked up over time. This is continually evolved and maintained. The workbook, by the way, does things like how do we actually do the things in question. And if you look at the last book, you'll see here. Is that it's going to talk a little bit more about reliability, how to apply it, things to like keep in mind, a lot about security, and then a lot about designing systems. I will tell you that if you read the content and even apply it and just like learn the principles here in these books, you will be top tier, and you will probably be in like the 1% of people in terms of who have actually consumed these books. Because even though they've been out for like 15 years, very few people actually read the SRE books. So after you get your KCNA, I'm just kidding. After you feel like you've mastered CI/CD and platforms and Kubernetes and stuff like that, I would say go read the books, right? Yeah. Kat, I want you to know that being an engineer in IT is, it's like living in a fire hose, right? You are constantly just sucking down new material. Okay, so the answer to that one was SREs are mainly about reliability, availability, and performance, so no confusion there. Let's keep going. We got 20 more minutes. All right, even though you know the clear answer is clearly B, let's go take a look at what this one is. What is a DevOps engineer's primary focus in cloud native environments? Okay, so here's the question. Must have 10 wives. Do you know how much work having relationships are? If you had 10 wives, you would be busy. That's a full-time job. So DevOps engineer's primary focus. Okay, so very similar to like application code, physical hardware strategy, marketing strategies obviously is off the table. So just know that if you get 10 engineers in a room and say, what does a DevOps engineer do? You will get 12 different answers, right? Because the recruiting industry has really mangled DevOps so that everybody is called DevOps. But I just want to say this, and I want you guys to take this to heart, right? The number one thing, if you are a DevOps engineer, the number one output that you usually have is automation, right? That's the number one output that you usually have, right? Is that your job is to try and automate things as much as possible. Now, if you can do it collaboratively, if you can create culture, if you can be data driven because you've got metrics, that's awesome. Like you can do the whole CAMS thing. But just know that the number one output of a DevOps engineer is typically automation with collaboration as a fast follower. And that's the idea, because if you're not actually automating towards a user problem, whether that user is a developer or a customer, you're probably like not really doing the thing, right? To act as a bridge between development and operations, this is the whole reason why for 10 years people wrote blogs that said, do not call your people DevOps engineers or DevOps architects or a DevOps team, right? Is because by doing so, you make one person responsible for bringing two disparate groups together. Unfortunately, we didn't listen. So the recruiting industry was just like, yeah, let's just call everybody DevOps because that's what people want, right? I saw the other day someone offered an SRE associate's position, which is really just a DevOps engineer, but whatever. So bottom line is that for KCNA, for our questions, we're just going to say that this is to bridge development operations through automation and collaboration. That's actually a pretty decent answer. It's not bad. Let's see. DevOps, the name itself, resembles development operations. That's true. Keep telling my org they need a systems admin, not a DevOps. Nevertheless, yes. Yeah, that's probably accurate. Most of us, by the way, start up as system admins, right? We're administering Windows or administering Linux, hopefully Linux, although I don't have a thing against Windows. I just recommend it. We start out as system admins and then we evolve, right? So, yeah. So, DevOps is not a tool, it's a method for SDLC and SDLC. Shadow, I would say that it's a little bit outside of SDLCs. Without DevOps, we can get entertainment from Dev. Yes, you can. But I mean, honestly, whenever we get two groups of people together, there's a lot of friction and drama. So that's usually the case. Okay. Like I said, 10 engineers, you ask DevOps, you get 12 different perspectives. By the way, if you ever read the DevOps handbook, make sure you search for the dirty little secret of the DevOps handbook. It is literally called the dirty little secret of the DevOps handbook. If you ever decide to read it, go look it up. Go figure out what the dirty little secret of the DevOps handbook is, because it's shocking. Most people have not picked up on that, quote unquote. It's called the dirty little secrets. Literally says that inside the book for the DevOps handbook, if you've ever read it. Maybe I'll answer that question next time. All right, so what is OCI? What's the Open Container Initiative, right? Again, we seem to be stuck on B as the answer, but I think you get an idea of like, it's not a cloud service provider, right? It's an open and governance structure for creating standards around container formats and runtimes. Okay, so then the Open Container Initiative basically helps us define how interoperability and standards work when we package containers, right? Now, if someone said, oh, well, what's a container? What's a container? If someone said, how would you explain a container? What would you go for? Guys and gals, and everybody in between. What would you go for if someone said, explain to me what a container is? Shanu, you're exposing answers like NodePort. That's a good one. If you're going to explain containers, right? Well, but hold on, nevertheless, it doesn't actually use a kernel, right? So we can't call it a lightweight virtual machine. Although that's a good analogy, it's technically not correct to call it a virtual machine. Basically, a process in a virtual machine. I agree with that. So then if we have virtual machines and we have containers, what are we virtualizing? What are we virtualizing when we like make a container? Because nevertheless, I think you're pretty close to it. We are definitely virtualizing resources, right? We're definitely, in a sense, like we're isolating virtualizing process space. We're isolating virtualizing network space. We're isolating virtualizing storage. But we are actually dependent upon the OS. So even though we're like, you can't take a Windows container and run it on a Linux system, right? But we're not virtualizing at the OS level because the operating system is already virtualized. That was pretty close. I'm not sure who 44616E is, but that's very close, actually. Yeah. So if someone asks you what the difference is between a virtual machine, hi Dan, good to meet you. The difference is between a virtual machine and a container. One is operating system virtualization, the other is process virtualization. So if you're familiar with BSDs and jails from like the 90s, the containers came from this, and Sun Solaris had containers back in 2005, 2004, right? So the idea is you're taking a process, you are virtualizing it, you're isolating it, and then you're adding virtualized networking and virtualized storage to it, right? So think of virtual machines as you are virtualizing an OS. Containers, you are virtualizing a process. That's it. It's the simplest way to think about it. You are literally just jailing and virtualizing a process, and you're giving it resources. So just remember that. So the Open Container Initiative is an attempt to define the standards that you use to virtualize a process. That's what it's for. Very different from, I don't even know that there is a virtual, like a OS virtualization standard. I'm sure someone's come up with one. But the OCI is what we use when we want to standardize the virtualization of processes inside of an operating system. Process or application, same thing, Celine, right? An application is just a process, right? So, um, so to answer your question, I think the Docker shim was necessary to start with because the guys who designed Kubernetes and the guys who designed Docker purposely didn't talk to each other. And so that was done by design to make sure that there was no crossover. I actually talked to Solomon Hayek about this, the guy who invented Docker. So, yeah, I think Mumshad did it. I think Mumshad was with me actually when we had that conversation with him, where he was like, "Yeah, we didn't even know the Docker guys were doing their. I mean, the Kubernetes guys were doing their thing, right? They were purposely isolated, so that's why Docker shim was necessary." All right, so then evolving away from the OCI, what's the purpose of the CNI? Like, what is the purpose of a container networking interface, right? I know, right? There's actually a different answer. Maybe somewhere in a special universe, a pocket dimension far, far away, machine learning took hold, and then I actually changed something. So, okay. All right. So then, what would change, by the way, if that said CSI, the container storage interface? What would that be about? Because you got it right, right? It's A, to provide a standard interface for configuring network interfaces in containers. Because remember, we said that the OCI defines how processes are virtualized, right? So if we're doing a CSI like a storage like interface, right? What changes is that now we have a standard interface for storage, right? There we go, Kat. Yeah, exactly. So the idea here, and by the way, security is usually either baked into the CNI, the CSI, or you're using something else, emission controllers, whatnot, network policies. So the idea here is that the CNI basically says this is how we're going to like standardize networking inside these processes. A CSI is this is how we're going to standardize storage inside of these. Like it's a standard interface for storage in containers. So yeah, good. We only got 10 minutes left, so let's go through the next one. I can't believe that. Everyone, note this down. The answer was A this time. It was not B. Amazing. Maybe there's hope that next time we can actually weave the answers around the different numbers. Okay. Question 13. I know, mind-blowing. What type of scaling does vertical pod autoscaler, VPA, provide? I know. Now we're back. We're just back. We're back to the known, predictable, right? It's going to be all about scaling the number of cluster nodes, right? Because that's what we use vertical pod autoscaler for, is to declare the number of cluster. No, yeah. So obviously it's not cluster autoscaler or the cluster node autoscaler, right? It's all about upsizing what's going on with the individual pods. Now, I will say this, is that this answer is probably going to be changed to dynamic allocation as soon as 133, 132 becomes very ubiquitous. But, or like we're forced to upgrade, which will probably be in about 18 months. But I don't think anyone's going to use the vertical pod autoscaler again. By the way, how many of you ever used a VPA? Like in your production setups? Don't worry, Kat. We're still crossing the multiverse. So it doesn't seem like a lot of you have actually used VPA. I meet very few people. I probably count on one hand the number of people in, almost 10 years of using Kubernetes that I've met who actually have used the VPA. So, correct answer is B. I know that's such a shocker. Yeah. Nevertheless, I think you're right. Usually, I think you're absolutely on the mark. Availability is usually the problem, not like upsizing. We can always make copies of stuff. Usually, the main issue I see that with is like databases, but most of us are not using transactional databases anymore. I say most of us. Some of us are. All right, dang it, it's going to show up. I almost pulled that off, but you would have known it was B anyway. All right, question 14. Okay, this is another one of those things that if I get 10 engineers in a room and I say, tell me what a microservice is, I get like 12 different answers. I've taught so many classes on microservices and gotten so many people's perspectives on this. It's crazy. Ooh, nevertheless, I saw that. There's still an active debate about whether or not we should have databases on our cluster. Yeah. I gotta tell you, adding state to an application on Kubernetes adds a whole host of complications. I would say you have to be really good. Like you need to be 6 months into stateless before you switch over to stateful. But honestly, the cloud providers make it so easy to run stateful